JWST has been busy in 2025. In its latest batch of images, we're not just seeing snapshots of space, we're seeing space in motion. Light echoes shifting over time, dust rings expanding, and galaxies rewriting what we thought we knew about the early universe. These aren't just pretty pictures, they're clues, and they're giving us a front row seat to cosmic evolution in action. So let's dive into the latest discoveries and why they're shaking up our understanding of the universe. JWST started strong in 2025 with its release of 2 images of the same object taken 14 months apart. And while these images don't look like much side by side, in fact they look almost identical just side by side, but once you flick back and forth between each image, you can watch this object actually move and change. This is Wolf-Rayet 140. It's a binary star system about 5,000 light years away in the Cygnus constellation. And honestly, Cygnus gets all the cool space stuff. It's got this, and it's where the first ever black hole was found, Cygnus X1. But anyway, back to Wolf-Rayet 140. Here's what's happening. One of the stars in this system is a Wolf-Rayet star, which is a type of star that is incredibly rare, massive, hot, and nearing the end of its life. Now, when these stars die, they either explode in a massive supernova or simply collapse completely into a black hole without a trace, which is just absolutely epic. The other star in this binary system is another massive, but not quite as massive, O-type star. And these 2 stars orbit around each other in an elongated orbit. Every 7.93 years, they make their closest approach. And when they do, that's when cool stuff happens. One thing I didn't mention about stars, like the 2 in the system, is that they eject a lot of stellar material. And when these stars get to their closest approach in their orbits, their stellar winds collide and compress, forming these rings of carbon-rich dust. But you may have noticed that these rings aren't perfect circles. That's because of the way the winds interact. The dust gets sprayed unevenly around the stars. And from these images, JWST has revealed at least 17 concentric shells expanding outwards, and they're moving at nearly 1% the speed of light. That's 2,600 kilometers per second. And thanks to JWST's observations, we can actually see the dust moving over time. Eventually, the Wolf-Rayet star will go out with a bang as a supernova or quietly collapse into a black hole, but the dust rings, they might just outlive the star itself, continuing to drift through space for hundreds of thousands of years. We also got some new science from JWST that seems to be getting us closer to solving a mystery that JWST started in the first place. Astronomers first spotted these little red dots in deep space within the first 6 months of JWST's operation. When they spotted them, they weren't just another group of distant galaxies, they were a problem. And a big one at that. These galaxies appeared way too bright, way too massive, and way too numerous for our current understanding of how galaxies form and evolve in the early universe. So what's going on here? Well, thanks to JWST, we can peer back over 13 billion years to when the universe was just a little baby. And these little red dots appeared between 600 million and 1.6 billion years after the Big Bang. They looked unusually bright, which initially suggested that they contained an enormous number of stars. Far more than what was expected for that time in cosmic history. But then, scientists took a closer look. Instead of stars, they found something even more extreme in these galaxies. Rapidly growing supermassive black holes. These black holes were devouring matter at incredible speeds, generating immense energy and boosting the galaxy's brightness far beyond what the stars alone could explain. Now, some of these black holes are what are called overmassive black holes, making up either 10% or in some cases even as much mass as all the stars in their galaxy combined. That is unheard of in modern galaxies. For comparison, the Milky Way supermassive black hole is equivalent to the mass of 0.0003% of the mass of all the stars in the Milky Way. Are you shocked? Because I'm shocked. Like, I expected that number to be small, but maybe just not that small, you know? Anyway, enough of being shocked by numbers. Let's get back to the mystery of these little red dots. So once researchers accounted for that extra light coming from the supermassive black holes in these galaxies, or specifically the disks around the supermassive black holes, the numbers finally made sense. The universe-breaking problem was no longer a problem. It was a clue that black holes in the early universe grew much faster than we previously thought, playing a major role in shaping galaxies from the very beginning. But the mystery isn't quite completely solved yet. These little red dots galaxies seem to disappear after about 1.6 billion years, and we don't yet know why. And strangely, despite their brightness, they don't emit a lot of X-rays, which we'd normally expect from active black holes. So what's really happening inside these galaxies is still quite a mystery. It's honestly a tale as old as time. As soon as one space mystery is solved, another one comes up just around the corner. JWST's January photo dump included something truly incredible, a light echo. Now, a light echo is like a cosmic flashbulb effect. When a supernova explodes, its burst of light travels outwards, illuminating dust and gas along the way. And as the light moves, it makes previously invisible material glow, almost like revealing hidden shapes in a dark room. Except this isn't from visible light. JWST sees infrared light, light that's redder than red. So unlike visible light echoes, these infrared echoes come from the dust that absorbs radiation and then re-emits it, allowing scientists to map 3D structures in unprecedented detail. Cassiopeia A is the remnant of a star that exploded around 350 years ago. Stop right there. You were about to write in the comments that this star, whatever its name, because we both know that detail doesn't really matter in this moment. What does matter is that this star didn't explode 350 years ago because it's much further away than that, 11,090 light years away to be exact. So technically, this star actually exploded 11,440 years ago. And while that's true and valid, it doesn't really make a difference in this explanation because we're talking about how it looks to us now, which is on an 11,090 year delay because of its distance from us. Drop a comment, yeah, if that was going to be you. I know there's always at least one. Anyway, back to the cool stuff. But the light echoes JWST observed aren't from the supernova itself. They come from unrelated material in the background, suddenly illuminated by the supernova's ancient flash. And JWST captured these echoes on 3 separate occasions, allowing researchers to create a 3D scan of the interstellar medium, kind of like a CT scan of space. Just like with the images of Wolf-Rayet 140, we're seeing space evolve and move in timescales actually relevant to us humans. Space isn't static, folks. These images reveal a complex layered structure of interstellar dust, almost like an onion or an ogre. Some regions are dense and tangled, resembling knots in a wood grain, and others are thin, filament-like sheets. And these features appear to shift over time, possibly shaped by magnetic fields threading through space. Now, this discovery gives scientists an unparalleled look at the structure of interstellar space. The small-scale sheet-like structures in particular came as a surprise, and analyzing these echoes will help scientists understand how cosmic dust and molecules are distributed throughout space. But there is more to come. Astronomers will continue watching these light echoes evolve, and with the upcoming Nancy Grace Roman Space Telescope launching in 2027, even more light echoes could be found, offering a deeper look into the ever-changing fabric of our galaxy. Finally, we have this stunning image, and while the background galaxies look amazing as they usually do, the subject of this image is this collection of blue-colored stars in the bottom right-hand corner. This is Leo P, a tiny dwarf galaxy about 5 million light years away in the constellation Leo. And unlike many other small galaxies, it's rather isolated, so it hasn't been disrupted by the gravitational pull of larger neighbors like the Milky Way. And what makes Leo P even more unique is its unusual star formation history. Most dwarf galaxies formed stars early on and then stopped, but it appears that Leo P had an initial burst of star formation, as per usual, stopped for a couple of billion years, and then restarted again with star formation still going on today. And this pattern changes what we thought we knew about how galaxies evolve over time. One of the things that JWST reveals to us is that Leo P has a very pristine environment, meaning that the stars in Leo P have a very low amount of metal present in them, just 3% the amount the Sun has. And this gives its stars a distinctly blue appearance, kind of like a time capsule of the early universe. Some of these stars are about 13 billion years old, making them fossil records of the cosmos's past. But when I first saw this image, one small detail stuck out to me the most, and it was this little blue bubble-looking thing here. This is a region of ionized hydrogen surrounding a massive O-type star, like the companion star in Wolf-Rayet 140, which is a clear sign of active star formation. Seeing this in such a small, isolated galaxy gives astronomers valuable insights into how galaxies like Leo P managed to reignite star formation while others just faded away. And speaking of size, Leo P isn't just small, it's really small. It's about the same size as some star clusters within our Milky Way. Yet, despite its tiny stature, it's proving to be a goldmine of scientific discovery, helping us piece together how the earliest galaxies formed and evolved. What JWST has shown us this year is that space is anything but static. And thanks to the telescope, we're seeing that in real time. From stars sculpting rings of dust to galaxies with supermassive black holes that defy expectations, every new image tells us more about how the universe evolves. Let me know which discovery blew your mind the most in the comments, and as always, stay curious and keep looking up.